Yeah, so once again, good afternoon, everyone. This is another PEPS industry lecture session organized by Electrical Department in IIT Hyderabad. So, let me begin by briefly introducing you with the title and introduction of the speaker. So, today the topic is Vedas, that is visualizing Earth observation data and archival system, that is the energy map of India and the solar energy calculator. And the speaker is Sushant Banerjee. So who joined in ISRO in 2012 and since then working in the National Remote Sensing Center of ISRO in Hyderabad. The center has ground stations for receiving satellite data, generation of data products, and remote sensing applications, including geospatial services. For capacity building for professionals, faculty, and students, there are various portals which consolidate various data into an applicable form. Such portals are Bhuvan, Bunidhi, and NDEM, NICES, Bhuvan, and Panchayat 3.0, Vedas, and MOS DAC. So these are several portals which have been developed by ISRO, I believe. So, so in this session, we'll explore the energy map of India consolidated in portal Vedas and use the solar calculator under this. And the presentation also involves a little bit of demo of the portal and the open source data that is available, and some kind of hands-on experience and some future endeavors. So with that brief introduction, let me hand over the screen to Sushant Banerjee. So he will be presenting it. Also, I should mention that Sushant is an external student doing PhD at IIT Hyderabad. Yeah.
Okay.
So over to Sushant. Please share your screen and
Yeah.
we can start.
Let me share first. Is it audible and visible to everyone?
Yes, yes, you are audible.
Okay. Okay. So is it your screen is visible here?
Yes, you can right away. You can start presentation
Okay.
while
So
more people are joining. Yeah.
yeah, good afternoon, all of you. So here we will have a glimpse of Vedas. So first of all, it is not Earthved, Yajurved, Samved, and Rigved. It is a Vedas. We call this portal actually. That is Web Interactive Portal. We will go through one by one. This is made by one of the center of ISRO, that is SAC, Space Application Center. Actually, many person ventures when satellite goes up, stabilize into the orbit. What happens afterwards? Okay, so satellites are made for the specific purposes, and a specific purpose related sensors used to be there. So every satellite has a designated objective to fulfill. So many satellites will be Earth observatory satellites, which observes the Earth. So mainly those data we collect and we give in a consolidated manner to the users, so that only they can take advantage of such data in the research, academia, and other research and development wing. That is only one of the portal is Vedas that is made. Let me go through one by one. What is the first word here which comes here? It is geospatial. So let me see.
Sushant, can you go to presentation mode?
Okay. So let me just brief you what is geospatial, because I have put here a geospatial map. Okay. So like you used to see the map, any map you used to see earlier, anything which is not related to location, real location is called a spatial. Like if you have a building map in AutoCAD or any picture of any building in your IITH. So if that does not have the real location, so that is called a spatial. Any geospatial means it has the location with respect to Earth. That location can be anything. Mostly we take lat long location for the object on the Earth, so that only it called as a geospatial. So because it is geolocalized form of map. So that is the main meaning of geospatial here. Map, and Vedas will go once. So here actually Vedas, that is the visualization of Earth observation data and archival system. So first word emphasizes like it is a visualization. So you need to visualize and you need to get the you need to see, you need to observe, and you can get the you can get the map and data in the form of PDF or anything, so that you can print or anything. So here the main thing is you are visualizing the all the datas. So if we go through the Veda website once, just let me go through. So this is the website. So here we have visualization of Earth. This is the Space Application Center. We have the center in Ahmedabad. This is, and just this is the home page. Let me go through what is the application. So these are all the application is given here with the data we receive from the satellites. So various data from various satellites for the various uses. So the diversity of the use you can see here. Satellite data visualization, that is another one parameter is there. Then vegetation, desertification, land degradation, new and renewable energy, air quality monitoring, snow and glacier, urban sprawl information system, USIS we used to say, hydrological science, wetland, coastal, polar science, forest, mobile-based few data applications are there. Special products are there, the planetary science and geospatial energy map of India. So this only the last one, the geospatial energy map of India, we will talk about, because that is related to electrical and our prospect for the next research or any project related. So just I want to show you the diversity of the data and how the people uses these data. So we'll go to, so this is only is written here, agriculture, those things are there, so I'm not repeating the same thing. And these are also aimed at meeting the requirement of various users, ministries of the country. Yes, actually this energy map is basically called by the ministry. Actually every other portal like DA, Department of Atomic Energy, has their own set of data for their generation and all. Like that coal power plants, they have their own set of data in Ministry of Power. But we did not have any consolidated data in one platform. So that this actually energy map is basically requirement of the ministry, and those only we have collected all the data and put in a platform with the definition energy map of India. So the silent features, this is about the Vedas. Just let me go through once. We will not go deep into this. This is, as I told, a satellite-based geospatial data visualization in 3D, 2D, and 3D we have, and the spatial and non-spatial search engines. Spatial, non-spatial are already said you. There's public web map services that we will get into that. Geoprocessing tools for analysis, that also we will see. Development of indigenous software, that is a servers we host, IGIS server, and they are providing platform for research and training to academia by providing data, domain knowledge, and infrastructure. This is the main objective of this platform basically. So we will go through the last application what I shown you, that is the Geospatial Energy Map of India. It is released on October 18, 2021, which is designed and developed by ISRO as well as NITI Aayog inputs. And with the data we have taken from 5 ministries, that is Ministry of Power, Ministry of Renewable and Non-Renewable Energy, that is MNRE, Ministry of Coal, Ministry of Petroleum and Natural Gas, Department of Atomic Energy. So I again say these all ministries had their data in their fragmented way. We have just consolidated these data and put in a one platform. Uh, so we will go through just a little bit of how we have proceeded for this energy map of India. Then we will go to the portal. So this is the energy data in India. So as I told, energy data in India is fragmented and scattered across multiple organizations, as the 5 ministries I have I shown you. There is no consolidated energy map available in India that may provide a holistic picture of entire energy sector. Actually, to nearly 2017-18, we had the objective to have 175 gigawatt of solar energy by 2030. So with that view of the ministry has so much emphasis on to have one platform so that only we can get all the information which can helpful to have the next energy like policy making and next planning for the energy sector. So with that objective only these things are being done. So the third point is that geolocation information is not commonly collected at present. The available maps are mostly in static form. Actually, the whatever the available map with the other ministries, these were spatial maps, not geolocated. So that is one of the thing. And the maps are not updated regularly, making them less reliable for decision making. That is, of course, now even it is also happening. That also we have a problem that I will discuss you later. So this is web GIS based information data website in India. So let me go through one by one. So this is web because it is you can see on the web portal. GIS, let me just have one introduction of GIS. I'm not going into depth of that one. GIS is Geographical Information System. uh, Actually, what we do in GIS, we used to have the geolocated asset. We can design, we can map the geolocated assets of any region or area. Like if I say IITH, I need to put the IITH campus into GIS. So what I will do, I will take the perimeter one map. I will take the satellite image of IITH campus, the whole campus. Then I will take the uh, perimeter, that is one layer we used to call layer. Okay, that is one layer. I will take the perimeter. One layer I will take all the roads, that is main road or small roads. One layer I will take all the residential building. One layer I will take all the academic building, and one layer I will take the for sports and those fields and recreation facilities. So if I take all the five layers different and put into a platform overlapped with each other, I can get the full geolocated area map of the IITH. So is it okay? You got the thing how we place a an image to a geolocated place with respect to different layer. We superimpose one by one over one. Like see, building will be in one coordinates, roads will be in one coordinates, perimeter will be in one coordinates. If there is some water body, we will put in one coordinate. So these all things are one layers actually. And then we superimpose all the layers in one platform. Which platform? That is software we have. What are the software? There are mainly two softwares. One is open source, one is licensed version. Open source is QGIS we use. Anyone can download the QGIS and do the same thing. One, the licensed version is ArcGIS. So licensed version or ArcGIS. ArcGIS has little bit more advanced uses, utilities, which QGIS does not provide. So this GIS is okay, means how we are putting this one each another each and making it a geolocated map of any area. So with that one, I proceed now. Okay. So okay, so it is web GIS based energy data websites in India. So that's why it is GIS based data. So in this we have few things which is solar calculator, like national power portal, online coal block information system, substation and transmissions lines. We will go through these things. And other like examples, we have India online exploration database, coal mines surveillance system. All these are actually sector specific energy maps. An integrated information system for energy sector is thus needed. These all were individual. So now we have clubbed everything in one platform. So these are the integrated web GIS based energy maps. These are the foreign whatever. If you go through, you can go through. Other like US also has energy mapping system, and these Australia also have energy mapping system. I have the link. If you want to go through, you can go through, and then you can compare how we can improve our system and how more easily we can give the data for to the others. So our objective here basically to develop a web GIS based information system for visualization of energy map of India, showing spatial and non-spatial data of conventional and renewable energy based power plants. That is the first one. We have conventional coal and everything is there, as well as renewable energy based power plants. Then fossil fuel resources, including coal mines, oil and gas wells. Coal mines and these things are very important actually. How much you produce, how much you means sell. So these things are very important for the ministries to go through. Oil refineries, ethanol plants and terminals, then pipeline and electricity transmission lines. We have a substation as well as electricity transmission lines also in that map. And then renewable energy resource potential. So this is like how much potential we have the renewable energy resources. So that we used to take from GHNI, how much insulation we have in each place, and we used to give the potential of renewable energy for that specific location. So here actually the software, the software is made with the open source technology, and the software and in-house software. The technology is used actually open source. The languages for the software and all, and the software is in-house. All thematic layers are shareable using OGC compliance. This is one compliance actually. Uh, that is Open Geological Geoinformatics Consortium is there. That compliant we need to fulfill, and this is Web Maps Services, WMS, for interoperability. This was the project timeline was given to us. So it started with the meeting from 2016, then 17 onwards, then 18. So mainly the work has been done in 20 and 21 basically, and during 19 also the data were collected during COVID time, and 2020 also we had 50% of those at those times actually these alls were made, and 21 September it was launched. So data sources and nodal officer, just to have a view for all of you how this is, how the portal is functioning actually. So data for energy map has been provided by energy department and ministries, including Ministry of Power, MNRE, Ministry of Coal and Ministry of Petroleum and Natural Gases, and Department of Atomic Energy. So these all data actually for this energy map are provided by different departments. So we are not responsible for like how means validation we used to do, but how correct this data is, that is the responsibility of each ministry who are giving the data. So with respect to that one, this is just a consolidation with validation of data and correction of the data and everything. So nodal officers are appointed to give for the data collection. So those are from the different ministries. These are the persons. I'm not going through the name, not required. And then website is currently developed on Vedas portal of SAC Ahmedabad with this link. This so still actually this is 1 year, because we have launched in October 21. So just now it is 1 year. Many correction also we need to do in that one. Many places there is a problem with the data, like in it is not showing in the manner it should show. So still, once it is a foolproof, then we will plot this in the Niti Aayog actually in the future. Many feedbacks are coming for these things. So still we have to go through a little longer way to put this finally in the Niti Aayog in future. So as I said you, there is a different layer as while making you understand the GIS, I said you the different layer of IITH like road and all. So here these are the layers actually, and like layers of CEA, like coal power plant, they have given Central Electricity Authority, diesel power plant, natural gas. These are one of the layers. So all layers, like 27 layers. We have put more, but at the time when we launched, that time there were 27 layers were there. So these all were taken from the different ministries and has given in a GIS platform. In this bioenergy potential is our data, ISRO data. So what is the input actually? So input we received in a different format, many formats. In our all, we used to give one format to them. In that format only they used to give, that is XLA, doc, CSV, PDF, KML and shapefile. These are used in GIS software, shapefile and all. Then we use the data cleaning and schema mapping we used to do. Then data is organized in DBMS, that is RDBMS, relational database management system, and then all the energy layer we put and we publish. So this is the energy map of India 2021. That was the main figure that time. So all men were these are the legends were actually conventional power plant. We had coal, diesel, natural gas, nuclear, hydro, pump storage, hydro. Then coal mines, all lignite mines, all mines were there all also in coal reserves. Then renewable energy power plants, that is small hydro power plants, solar, wind, biomass, small hydro, waste to energy, and then petroleum and natural gas. We will go through each. So data editing and update. So nodal officers, I have shown you earlier, send data to ISRO in CSV or ESRI shape file format as per our agreed table structure. We used to give a format that is in a table form, and they used to give us in that table form to us. So edit feature attributes online using web interface provided on the portal. There are three-tier editing mechanism, that is edit user, nodal officer has to edit the data and approve the changes, and administrator is there who used to approve the changes by nodal officer. So these are three layer of the editing mechanism, so that only what we publish should be a foolproof data or map or visualization of the data. Then fetch data from external server using API. Okay, this has been implemented by updating the following. That is the monthly production data of coal mines. CIL, they used to update the data very nicely, so we don't have any problem with CIL. They used to update very good. If you say to yesterday's data, they will show you the data that much. Monthly electricity generation of the conventional power plant monitored by CAA, but other many ministries we don't get the updated data. So that is one of the lag what we felt in this 1 year. Many data are not actually updated, so that reduces the value of such platform basically. So that is the data security and integrity issue. So actually we have DST's Department of Science of Technology's few negative list when we are putting something assets of the country in an open platform. So we used to see we need to see the data security also. So there are some negative list of the DST that you can go through in DST's website, so that we should not publish, or the whatever we are showing that should not be visible so much. It should only show the shape and all, should not go inside the any power plant and sheen the thing like that. There are some what to say resolution that limits are there. So we are just declaring that we are compliance with every those list and for the security aspect. So hardware and software also level check. It is done by a third party also, CDAC, then STQC and NIC used to do the hardware checking for the there for validation of the same. So end use and application of GIS based energy map. So benefit of GIS based, what are the benefit? Actually, it provides a holistic view of all energy related activities at one place. That is the main objective. So all thematic maps are available to users anytime, anywhere. So actually thematic map means one theme wise theme. So what I told you, like layer wise layers, that is actually theme wise theme, thematic maps. Enables integration of energy layers in other application using WMS services. That is potential applications. So that is policy development and planning to minimize regional disparity. Like a state government and central government will have the disparity over a few things, so that they can do the policy development and planning according to this website's input. Then investment guidance for financial institution, like next how much solar power plant they need to put, where it has to be put, whether it is correct or not to put in that, how much we are gaining after investing. So such investment guidance are also possible from this platform. Disaster management and emergency response, these are also there because we have wind velocity are also there, river, we can put the satellite real-time satellite image also. So if satellite image shows ki yes, there are hurricane or cyclone, there are a hurricane or cyclone in the Bay of Bengal, so we can have such a mitigation plan also. Okay, so that also can be there. Then education and mass awareness, that is the main objective. So we will go through the website once. So is it visible? This is the energy map of India. So we have, so we are going to Vedas, then application at the last. So if you click this one, this will open. This will open. So once we'll go one by one, each link here. So this is the overview. We are not going through much, only there are overviews. Whatever I told, the same thing will be written here. We can go to this. So this is the first thing we get in that one. So there are the left side, if we see, there are layers. Okay, so there are different layers. Layers means these are the all the layers. What are the layers? A power plant. In power plant we have coal, diesel, hydro, small hydro, then natural gas, pumped storage. Then next is district wise RE installation. So if you have to go district wise, then we can go to district wise. Then district wise RE number of plants. So these all numbers are actually number. Core power plant we have 209. Diesel power plant we have 17. Hydro, these numbers are actually numbers actually. And if you, this is metadata. Metadata means the detail of the thing. So if we go this one like core power plant, if I do the metadata, so layer name, that is core power plant, feature point. This feature is actually a thing, a point in the actually GIS map. So this is a type, a power plant is a point actually we call, that's why it is point. Don't like think it is a other thing. It is a point in GIS. We use we use such methodology or the name actually. So it is concerned ministries, Ministry of Power, that is the website. So that is the scale. Then geographical, this is map datum, this WGS, that is 1984. That is one reference point actually. We use 84. We earlier we used 66, 73. Now we are using 84. This is related to GIS. I'm not going into this one. Then last updated, this is 2020. See, so this is only like our main problem is, so we are not getting the correct updates. So 2020 it is updated last. Nodal office name, this is the officer, the who is the chief engineer and all. So this metadata we can get it, so that only if there is some problem or we are not getting the correct data, we can directly contact them by their email, by their ministry or phone number. These are the legend. If we give the legend, so what is the coal power plant, that legend will be seen here. Red color is the coal power plant. So these all are the installed capacity. So we have coal reserves. These are very important. Coal reserve for the ministries and all. Coal reserve. Then we have petroleum and natural gases. See, each one is the each layer actually. If I put, it will come. If I select, it will come. If I just remove, it will not come. So accordingly, in one frame we can see many things. I will show you how we can use it actually. So see, if this is a coal reserve, if I click in that point where it is in Rajasthan. So it will give you the name, that this is the plant name, something Giral TPP. This is district Barmar, that is in Rajasthan. And what is the capacity? 250 capacity. So we can have the all the detail. If we click anything here, automatically it will come. Then we have transmission line and substation. See, we have 12,833 substation of different kV. So all KVs also will be written here if we click in that one. Then the renewable sources. So here we have hydroelectric power plant, total bioenergy potential. Then horizontal, this is only GHI. I was saying you that we can have GHI. So where how much potential is there for the irradiance, we can get to know, and accordingly we can plan our solar plant or rooftop plant or rooftop solar PV system to install. Then average annual insolation, this is for 2009 to 2020. So for that many years, the average insolation is mapped here. So that much data we had, and from that data we can get to know that how much the average annual insolation. This is actually per year, the GHI. This one actually fully in megajoule and per meter square. That is fully for 2009 to 2020. So wind power potential. Also, these are the different legends for the wind power potential. Once we'll go through. Then state-wise information. If I go through a state-wise, each states, that also we can get it through here. Then there are reference layer, like reference layer are infrastructure where airport is there, where railway station is there, where railway tracks are there. So these are the important when you go for the planning of anything, planning of any power plant, any coal reserve, anything. We need to have where the how much distance there is a railway track, how much distance the road network is there. Then we have administrative, like administrative boundaries. These are only the administrative boundaries. These are the state-wise administrative boundaries. Then base map, that is from taken from map of Map My India. Then it is a satellite image is also there. Latest satellite image, if you see. So these are the latest satellite image. So these are near real time. Okay, so that's what I was saying. If somebody is plan, even if you mm, for 3 days 4 days, if you do next 3 days, what will be the picture, that also we can get to know from here. Then these are the river streams. So if there is a hydel power plant, we can get to know hydel power plant. So once we'll go through the solar ones. Where is solar? Okay, so we will remove coal ones. So these are the solar plant we have, that 34,401 megawatt. And if we click like, so these are the legends. If you want to see, these are the legends. Okay. Let me log in once so that now we can get more information. Let me log in once. Okay, login you can do with a registration of your registration of with your email ID, name and department or anything, student or organization. You can do the registration, and so it will, you can log in with that one. So see, if we log in, we can get more information basically. So that's why login is required. So if login is not there, we can get less information. So this is the Jodhpur. If just I clicked one, this is the Jodhpur photovoltaic. So total capacity is 3,832, and power plant number is total 141. So if you go to more info, so we can see all the developer name. So project location in Jodhpur, where it is actually. So what is the district? That is Jodhpur. That Jodhpur itself is a district. So what is the ground mounted? These things are, and these are the installed capacity. So it is 0.9 megawatt, 1 megawatt with 10 megawatt. Data period 2020. So like that we can have. So we can put now potential. So this we can see, this is the annual installation. So I'm just showing the annual actually installation 2009 to 2020 around our these things. If you remove this solar, see the legend ones. So here you can what how many clicks you will do, all the legends will come here actually. So this is the annual solar installation. These are the in megajoule per meter square, and these for the GHI, global horizontal irradiance. So accordingly, this map we can plan where we can have now means next power plant where we can put the CSV, concentric solar power plant, or we can have the rooftop power plant.
Yeah, Sushant, I have some questions here.
Sir,
So right now, what you're showing is the dots in the map. They are actually the installed capacities.
yes.
So okay. So can we know what is the total installed capacity from this map or something like that, or we only get the individual information?
That is individual, sir. Total capacity of sir, that also we have. We have the total capacity of India. You are saying, sir.
Yeah, or yeah, whatever. Like
We have, sir. We have. I will show you once. In one consolidated form, we will be having.
and what about the like? If we go into details, we'll come to know the date uh, when this source has been added, something like that.
Sir, it is yes, sir. We will get to know once I just know. This is the GHI bits. I just remove once. Only solar plant I keep. Yeah. So data are up to 2021.
Okay. I
If
think, but then eventually everything will get updated, right? So
sir, actually no, this is only the thing. How much means updation they do or how much data they give. That only we can be putting here actually. Ah,
yeah. So
so
basically, what you're showing this platform, Vedas platform, is created by ISRO, but the source of data is from various different agencies,
yes.
and you're trying to get the data, clean it, and then create this kind of database.
No, in this one rectification, not Vedas platform. Vedas platform, we have many things from our side. Only the energy
Okay.
map of India. Okay.
Okay.
This energy map of India in the application of the Vedas platform, we have taken the from all the ministries and we have put up. But
Okay.
in Vedas, the other application like coastal oceanography and
Okay.
forest and those things are all our datas only. So those things
Okay.
are means very much these things means our data we used to update.
So can you show the maximum resolution, like how detailed the data is if you
Okay,
keep zooming in?
sir. As per it will not go fully inside.
Okay.
Means it will show only a point actually.
Okay.
Uh, it will
So
not
for
show.
example, what is the capacity here? Can you just select this one?
So it is installed capacity is megawatt 3832.6. So it is a means adding of all the capacities in the sense it
Okay.
must
Looks like,
have.
the entire,
Yeah,
like,
yeah. So
okay.
it has like 0.9 1 1 1 10 10 in megawatt. So adding those all capacities. So as per our norm, sir, we will put only point in these things. We will
Okay.
not show the power plant for the security reason and all.
Yeah. That is understood. Yeah.
Yes.
So what about wind?
Sir, wind also we have. I show you. And we can have wind plus solar like that also we can have.
Yeah, the next line itself was wind, I saw. Even you have waste to energy, so many other
Wind
things,
energy and wind
biomass.
one is wind potential is also there.
So the yellow colored ones is the wind, right?
Yes, sir. So no doubt, sir. In Tamil Nadu and all, we will have more
Yeah.
these areas. And wind power potential. See, if I the watt per meter square, I put this one also in a layer. Okay, so this is the potential of the wind power. So
Okay.
wind power potential versus whatever we have, wind power plant we
So
have.
what is the benefit of comparing these two?
Next we can use, sir, means next where we need to put the wind power plant in future,
Okay.
or whether we can increase the means existing wind power plant, or if wind direction is changing, then we have to get rid of wind power plant.
Okay.
So
Good.
wind power here, like coal is also done.
Yeah. So anyway, so I think we have about more 20 minutes time until 4 p.m. I think the session has to end at 4 p.m. So
Okay.
requesting other audience to interact with the speaker. If you have any questions, feel free to jump in and ask your question. So
Okay.
meanwhile, if anything more you would like to show, that also you can continue, Sushant.
Yeah, I just request, no, I have to go one more, that is the tool of solar insulation
Okay.
tool. Just I will go
Yeah.
through once. Just I want to show you just these things. All you can go through one by one, and then you can superimpose the layers with each other and can see your result, whether it is like, like if I want, see, one thing I show you. If you have this is the interactive actually map. I show you one thing, just the time is less. Like I have here, so solar power plant, I have solar power. Okay, this is the solar power, and I have, where is the this global horizontal, this GHI also I have. Okay, you have two inputs here. Okay, so like you have the potential where the insolation is more, you have the power plant where it is more. Now if you want to select, I need to know the land aspect also I need to know. So here we have the land. Okay, like land use cover, we have the land. Okay, but in this land it does not show what type of land it is. So if a person now want to see whether it is barren land, whether it is shrubs, whether it is agricultural land, then only we can plan ki, yes, this place we have the potential also, we don't have power plant, then we can fix the power plant. So in that way you can use this upload file. You can have one layer, separate layer of the barren lands, that also you will get from our website only, barren lands website. And then you can put that one as a JSON file, KML file, and you can upload, and then you can see your means final result. You can show to your professor, yes sir, this is the perfect point, perfect area for the solar power plant, because I have that much solar global insolation. I don't have any power plant here, or I have the power plant which is less in capacity, and also I have barren lands which I can take in very less price. So like that, or you can plan for CSV, concentric solar plant, that we don't have in India, very less we have, if we have also, so that we can use in the barren land for that one. So in that respect, if anybody thinks to use such data and maps in their project in their future, to get any idea, so just go through one by one. If I go through one by one, it will take so much of time. Go through one by one, and then just take your result. You can edit this map, you can do your own thing by uploading your file. You can download these features in a file in a JSON format, and you can later convert also. You can put draw polygon here. These are the tools are given, so that if you want only one area, it is not geographical boundary of the state, you want just one area between Maharashtra, Telangana, and Karnataka. Okay, so you can put the polygon, and you can do your you can do your analysis. You can put draw a line, and you can see the distance also. You can put a line, 1 point to 1 point, and you can see the distance. You can draw a point feature if you want to put any particular point you want to do anything, and then you can measure any area also. It can be there, length, anything you can measure. So that's why it is very much interactive kind of map, so that only you can use as per your thing. Readily you are getting the data available to you, and finally you can print the map in any format and you can use that one. So let me go through this one, solar, that calculator once. Metadata, as I told you, metadata is actually detail of anything. Just I click once, just show you. Like this is the coal power plant, who is the concerned person and all like that. If you go for diesel power plant, who is the concerned person to whom you need to contact. So you can contact, and if there is any feedback and all, you can give to them directly. That is metadata. The user guide, these are the what I saw only important links we can go through. So here one we have solar site selection tool, and one we have solar calculator. Just we'll go once. Okay, so as it is, I told you the first input we will have lat long. Okay, so 7834. If we can take IITH lat long, I think it is.
Before we go to the solar calculator, there is one quick question.
What, sir?
In the chart, it is there. Can we have a map of renewable sources and its utilization?
Map of renewable sources and its utilization.
Yes. In the chart only it is there. You can see the question.
No, actually, see, can we have map of renewable sources? Utilization map. We have the map of renewable sources. That is in one series fully. It is there. I can show you. Utilization map. You need to do it. We don't have the utilization map. Utilization in the sense you are saying how much potential we have versus how much we exist, where we are, and how much potential we have.
So the installed capacity can be considered as a utilization.
Uh-huh.
Assuming that whatever plants are installed,
No, but
they're
I
operating.
think his sense is whether we are utilizing the full potential or not. So if we have the map for the full potential, how much it can be there, and we have the information for the existing. So now you have to compare which renewable sources are fully utilized and which renewable sources are not being utilized. So that can be a separate map also. Is it okay? Am I clear to my point? Okay, I think everyone is mute. Okay, Renjuji, thank
Sure.
you.
Yeah, you can go ahead with that solar calculator.
Where I was? Okay, so just quickly we'll see once. This is a tool actually. So this is like you can download in your see Vedas also you can download in your Android app. For the movability and all, it has been done in that file. ISRO this calculator also you can download in your Android and you can use it basically. So main input is actually the lat long. Okay, so I think this one Hyderabad, I think that is 13 and 78 is okay. Okay, we will okay, this is Leh Ladakh basically. Okay, so Leh Ladakh. So see, when we put the lat long, so automatically the location will come here with the pin code and everything. So with the statistics of the earlier data, we will have how much will be the minimum day length and the maximum day length. Okay, so this is the minimum, this is the maximum. Just 1 minute. So average temperature we have, so which is Leh Ladakh, very cold, is -2, +2. Tilt angle for the PV also is calculated here. So 29 degree Celsius, we need to have that tilt angle. So in average, actually twice we need to change as per the this one. Actually in yearly twice we need to change. So if we change, we need to have these angles. So the annual insolation is that much for 1532 kilowatt per, that also we have. Then power production of that many, considering you can make the efficiency of your solar plate, like whether it is whether it is mono, whether it is poly. Accordingly, you can use this 15, 16, from it starts from 15. you can give 20 and whatever your efficiency is, and then what is the area of your PV, that also you can give. This is the area of our PV. So in this area, at this lat long, with this tilt angle and with this global insulation, what should be the 8.4 unit per day? So it should come 8 unit, 9 unit per day basically with this one actually. So recently, when our team has gone to that one power plant, there also we have solar power plant. So they were comparing how much we are producing solar versus how much it should be. So that time I asked them how you are calculating per day how much it should be. So they also told the same thing. They are calculating everything and mathematically, and then they are saying how we are producing more than that or less than that. If you are producing more than that or equal to that, you are very efficient, nicely you are doing, maintaining the solar plant very nicely, and that should be there.
Sushant, just for the sake of understanding, see here, you're mentioning in Leh Ladakh district, right?
So this is Leila.
So here you're expecting 3064 units in 10 meter square.
Where, sir?
The total output that is expected is
Not 3000, sir. This is 300. No.
so that is for 1 meter square. Okay,
Yes.
I was reading the next line. Anyway, so
Okay.
306, right?
Yes.
Kilowatt hour per meter square per year.
Okay. Okay.
Now, just
Okay.
for the
Okay.
sake of understanding, if you select a place somewhere, another location,
Yes, sir.
how does it compare with this? So 306 in Leh Ladakh, right?
Yes, sir. So
So in
let's have
Hyderabad, how much it will be?
IIT or Telangana
Yeah.
lat
You can
long.
try that.
So we can
We-
compare what is the lat long
Yeah.
of
Oh, you want to do it in a separate page? Okay, go ahead.
lat long.
Can't you directly select on the map?
That also we can. I was IITH fully. I was
Okay.
yes.
No, approximately you can.
Okay. So we can have Telangana. Okay, 78 and 17. Okay, so north and east. So this is 78, 17. Okay, so north and east. So it is what?
No, I think you should submit. Yeah.
Just submit. So it is what is Siddipet district, Telangana, Cherial. I
So
don't know
it
the place. Okay.
comes to 352.
So it is 9.7 units per day. So it has increased for the
Yeah.
same 20% with
Yeah.
10 meter square. So it has increased.
And monthly averages also temperature is there, and
So
then
here
solar
actually, sir,
installation is there.
many things matters, like how much day length we are getting the solar, whether it is in sun path or whether we have, means Leh Ladakh means there will be mountain.
Yeah.
So the time of the solar will be very less. There will be shadow. Okay. So
Yeah.
with respect to that one, like it will there it is little less. Here it is more. So this is the monthly temperature versus solar insolation versus monthly solar insolation. This is actually 2009 to 22, 9 to 21. Year wise till 22, till November it is given. What for this location, for this lat long. So 2009 to 22 yearly total, like month wise we have how much units per meter square we are getting, we should be getting.
Okay. Okay. So we have about 5 more minutes, and I
Okay.
think there is one more question in the chat.
Okay,
Maybe
sir.
you can address
Just
that.
I go through once. So this daily average insolation, once just this is actually we are comparing insolation with respect to days as well as temperature. This is the temperature profile as well as the insolation. Okay. Sun path, what I shown you, sun path. Actually here means what is the azimuth angle with respect to altitude angle. We used to locate the sun basically with these two angles. So sun path also matters, and with respect to wind seasonal changes, it will change. With respect to lat long, also it will change. So this is the day length. There only I was saying if I put Leh Ladakh, so there will be changes in that one. Leh Ladakh is changes. So see here also it is the actually terrain horizon. If you see the sun pass also changes fully. Shadow profile also we can see here this area is full of shadow, this area no shadow from this hour to this hour, for this lat long, for this hour to this hour it is there is a shadow, while because the terrain obstacles shadow. So if we see the means Hyderabad or Telangana, we will not get this black shadow region. So with respect to that one, the total means potential for the solar that changes basically. And we have forecast chart also. We used to forecast for the next 3 days basically. So that is being now used by NTPC in one of their project in Gujarat. So they are using this forecast chart for their solar power production, as well as means when they will switch on solar, how much they will use the solar, and how they will use for the other conventional mode of power production. So this also is there. For 3 days we are doing the means forecasting thing with respect to our weather data and everything. So we had one more actually, just I go through just one more we had. Solar site selection, just I just show you once. This is the site selection. As I told you, there are many layers actually, a road, whatever layer we need, that will be there. Then here solar site selection, we can do how much angle means actually slope we have. uh, we can give the slope, then solar insolation how much we have, then distance from road, whether we need to have distance from road, distance from electrical grid, and then show data layer. Here we have the land uses also, what I shown you. If we go through like which land we need, shrubland, barren land, or wasteland for our solar site selection, that also we can give it. So as per input of lat and long, we can give these inputs, and we can see whether that site is good for the solar panel installation or not. So I just end with this one. Let me go through the, I have another, just go through once these all. This is actually in important links, here it is there in solar site selection, solar calculator. Okay. Okay, here nothing to say much. Once like 3D also we made once, one thing that only just I wanted to show you. Okay, just I'm saying you one, just it is now recently getting developed, so we have done for Ahmedabad. This is the 3D city model. Okay, so actually now rooftop solar is given very much means emphasis that everyone should have rooftop solar. If we want to know what is the potential of rooftop solar, then we need to do so let's see that this is the 3D model. Like we have taken the image of a city of Ahmedabad and Gandhinagar, and above that we have seen with respect to GHI how much, and with respect to area available to the rooftop, whether we can put solar PV on the rooftop or not. So this is the 3D city model just getting developed now. Just I just want to show you a glimpse. So this is the data for today's. Okay, so so see, the main base layer is basically a satellite map. Okay, so this is a ground. This is a basically satellite map we have taken from Cartosat. Okay, so this is the map of good resolution. This is a very good resolution. This is not any asset of the India, so that only no, this resolution will be very good actually. And where there we don't put that much resolution, so that's because of security norms and all. So here these are the potential thing where we can put the See, this is the very much red. This is little bit of orange side, and this is a little bit yellowish. In the sense here, the potential is less, maybe because of slope or anything kind of. So these are the very potential sites we can put the solar plant. So this is one by one we are doing that one city wise. So it will take time, and finally this report we will submit to the government, so that only they can make the policy like subsidize solar PV plant and all. So okay, already it is 4 o'clock. So once we'll go through, mm, because I have another thing meeting. They can we have map of renewable utilization? Okay, apart from wind power and potential, can we get the data of wind characteristics like wind speed? Wind speed you will get it. Wind direction also you will get it from a wind farm over a period. Yes, it is there. Wind character, wind speed and wind direction is there. I have not shown you that image. There will be wind direction. It is continuously flowing on. That real time it is there. Yes, there is a very much variation in that one. We have large coastal area. Do we have map of tidal wave power generation map? Yes, we have the oceanograph data. In that we have the this ocean coastal areas we cover. It is there. But tidal wave generation I need to see. I am also not aware. Let me go through. We have the ocean, seashore, coastal areas, marine maps. But this only for you are saying tidal wave power generation, that I need to see once. I also let me go through whether we have the tidal map or not, that whether we are showing or not. Okay. Any other things? Little bit.
Yeah. So any other final this one, or you can make your closing remarks, and we'll end the session. Yeah.
Okay, so no, actually we have many portal for different things. So this is the energy map I have shown you. Like that, we have a Bhuvan server which gives you many other parameters. Like you have said, no, like ocean, tidal, and all. We can get those data also from there. This is, but other portal we have the restriction to give data as per the users requirement. We used to give data in a restricted manner, and sometimes we charge also for the data. This is the open source we are giving freely, and the only things what we are facing the problem is, see, our platform can be foolproof only and reliable only when the data are getting updated in a daily basis on a continuous manner. But because it depends on the other ministries, and we are not like taking the data from them directly, they have to put they have to give it to us, and then we will publish. We are getting some lag. So that is one of the, after 1 year we are getting little bit. Few are giving the data very frequently, very nicely. Even we have given them login also, so that they can put the data directly, automatically it will validate and it will publish. But that also is not happening. So I feel with we have to do something to make this more foolproof and reliable, because if data is keep on coming, then only it is useful basically.
Yeah. So we understand that, Sushant. So already you have demonstrated that itself is phenomenal kind of work that has been done mainly from ISRO side, and along with the support of the others. So eventually, over in the next few years, I think it will become well advanced. I think it's very dynamic thing. Maybe on daily basis you are making improvements to this platform,
Yes.
and there's not much of awareness also. No, like a lot of people may not even know that such kind of rich data sources and resources are available.
Yes.
So good that you had presented this, so that now at least some people start using this data, downloading something and using it in their research and analysis.
Yes.
So yeah.
Okay.
So with that, I'll thank you. Any other final comments from audience or from the speaker? We'll take it. Yeah.
Sir, I have one question.
Yeah, quickly, please. Yeah.
Yes, sir. So, sir, as you mentioned that wind speed and direction data will be available. So, do we need to take that through wind calculator,
Wind
or
calculators are
can
available. Wind calculators are available. That is also
okay,
integrated with the wind speed and direction. So with respect to that one only, wind calculator gives the potential for the wind power plant. But if you separately wants to see, visualize the wind direction and wind speed, that is also available.
Okay, like do
Yes.
we need to in that website we need to explore and
Yes,
we'll get
yes,
that
yes,
data, right?
yes,
Okay.
yes. No, wind direction and all that images, no, it will should have, it will take some time to come because of resolution matters and all. It comes. Okay, I have not shown because of, but you have put the good point that also if I would have shown, that would be better. But it is available with respect to visualization, and wind calculates from there only, that direction as well as wind calculator we have. I have shown the solar calculator, wind calculator also we have. So that takes the data from there only and gives you the result.
Okay, sir. Thank
And
you.
then we can combine also, like, hybrid power plant, wind plus solar. That also we can do.
Okay. Thank you, sir.
Okay, okay, let me
Okay, thank
wind
you.
up. Okay, so Anand,
Yeah, thank you,
thank
Srishant.
you, thank you, sir, thank you for opportunity, sir, thank you very much.